Okay, welcome back. So we've talked now about measures of spread, how spread out data is, standard deviation. We've talked about measures of the middle of the data, the mean, median, mode, and mid-range. We have one last measure that we want to look at for our data, and that is a measure of the position of our data. So where does our data fall inside the data? And where does our value fall inside of the data? So it's measure of position. One way to measure the position of an object is to give it some kind of percentile rank, meaning that it's higher than a certain percent. So you may have heard things, you scored in the 85th percentile. That means that you're higher than 85% of everybody else in the set of data. They do this a lot of times with children in their early years, talking about their height and weight as far as what percentile they're at, okay, whether they're above or below the average. Okay, that's one way to talk about that. And we will see how to get percentiles in the next section. Uh, but in this section, we measure position a different way, measure position in a different way than that percentile idea. Since we know where the middle of our data is, right? We can compute that our we can compute that with our mean, median, and stuff like that. And now we know how to compute how spread out our data is. We actually talk about the position of a data item in terms of those two measures. And we call that a z-score. A z-score measures how far a data value is from the mean in terms of the standard deviation. The sign on the z-score sign indicates whether the value is above or below the mean. Positive sign, of course, would mean that you're above the mean. Negative sign would mean that you're below the mean. Okay. So there's two formulas that you'll see mentioned for z-score. Um, I tend to stick with the first one myself when I'm writing out things in the notes, just because it uses symbols that you're more familiar with. And the formula is simply z equals your data value minus your mean divided by the standard deviation. In this formula here, x is your data value, x bar is what's called the sample mean, and little s is called the sample standard deviation. Sample standard deviation. The other formula that you might see pop up is this one. Z equals x minus mu divided by sigma. Where the first symbol is this weird looking symbol here, and that's called mu. It's a Greek letter mu. That weird looking MU shape type thing. And then sigma almost looks a little bit like a cursive S, the lowercase sigma. And for those, x is still your data value. X is still your data value. Mu actually represents the population mean, and sigma represents the population standard deviation. Now, if you go on and take a full-blown statistics class, you will get into these other symbols, and there is a slight difference in problems. If you're dealing with this one or the other, there can be slight differences and stuff, but those are all things you get into in full-blown statistics. Yeah, full-blown statistics class. Uh, we're just dealing with position, and for us, it's not going to make a difference. So I'm just going to kind of stick with this formula. Although you may see the book mention the other one as well, but it's really the same formula as far as we're concerned. The two formulas are basically the same, using slightly different symbols, but uh, now that isn't quite the reality, but that will be good enough for us. So we'll treat them basically as we're just taking our data value minus our mean, whatever that's sample or population, doesn't matter to us, and then dividing by our standard deviation. So that's the formula for the position. And in the upcoming videos, we're going to take a look at using this.